Hello everyone, my name is Wolfgang Lorenz and I welcome you to our presentation of the paper Detection of Attic Extensions. The authors of the paper are myself, together with Arnold Faller and Gabriel Wurzer. All three of us are from Vienna University of Technology, Department of Digital Architecture and Planning. DAttE is the short name of a workflow that describes the detection of attic extensions. And why is that important? Because of the lack of knowledge which roofs are already expanded and to what extent. So we present a workflow and a script to close this gap.
The basic idea is to analyze 3D data in order to get information on whether or not a roof is already extended. The input is either a Lot 2 model or derives from photogrammetric recordings. And this data is then analyzed in a Grasshopper script and exported to represent the results on the internet. What we see here is the result of an analysis of a test case of a part of the city Vienna based on Lot 2 data. The colors gives the ratio between actual volume and the maximum possible of the roof extension. Red meaning a high possibility that the roof is not extended, while green shows the opposite. Why do we want to know about attic extensions within a city? Because they reduce the likelihood of demolition and new construction of a building. And this in turn is of interest since it influences the further development of infrastructure within the city, but it is also of interest in terms of material resources of a city. So, in short, we want to find out potentials for extensions and to get better data about material resources within a city. The idea of our workflow is to get 3D data of the city, especially about rooftops, and as a basis we use the Lot 2 model provided by the city of Vienna. And to improve the data, we also looked at photogrammetric and thermographic recordings. We wrote a script that turns the polygon network of the input data into 3D volumes. In doing so, it separates roof surfaces from the building or building parts. Thereby, the lowest point of the roof defines the fictive roof termination, means that everything above this horizontal line belongs to the roof floor. The maximum possible roof extension is then defined by a fully utilized story with a flat roof. And the ratio between the volume of the actual roof and the maximum possible gives an estimated degree of the attic extension. The clue about the Vienna Lot 2 model as input was to identify dormers and the like as part of the roof, but also to identify single building parts. This is important since building heights may change within a building. To improve the data, we also used photogrammetric recordings taken with a drone flight. The resulting shape is interpreted and turned into a form similar to the Lot 2 model in order to use the same algorithm as before. Another improvement concerns thermal recordings. This provides additional information on whether or not rooftops are inhabited. In our test case, it turned out that the resolution of thermographic camera was too small, so in the future we will have a closer look on that. The results so far are presented online as WebGL. This allows in the future to add parameters to objects and by that online participation. This means that citizens can add or adjust data just in time by using smartphones and wireless internet. However, all of this is the subject of future research. We have presented a workflow to detect attic extensions. The core part so far concerns a script that interprets a Lot 2 model or data from photogrammetric recordings. Both test cases so far proved the workability of the geometric interpretation. Future work mainly concerns the improvement of the quality of the thermal results and the incorporation into the model, but also the implementation of online participation. If you want to know more about this work, please have a look at the full paper. So goodbye and see you next time.